The last invited speaker is Dr. Wang ZhiQin. Let me introduce her very briefly, and would you play her pre-recorded presentations. She is a Deputy Director of CAICT China, and she has been a chairwoman of IMT-2020 PG and IMT-2030 PG of the whole cycles of 5G generation. So she will be sharing the work progress of the IMT-2030 6G promotion group. So let's welcome Dr. Wang.
Good morning, good afternoon, and good evening. Ladies and gentlemen, I'm Wang ZhiQin from CAICT. It's my pleasure to participate in 6G Global 2021. I'd like to give an introduction on the work progress of IMT-2030 promotion group in China. IMT-2030 promotion group was founded in June year 2019. It includes experts committee and 6 working groups. Currently, we have a working group for requirement, various technology and network technology, spectrum, standards, and international cooperation. This year, we newly established Economy and Society Working Group. Now, IMT-2030 Promotion Group has over 30 members. We are open to members around the world. The Requirement Working Group starts with the overall innovation and driving force for exploring the application and services of 6G. Based on the global 5G development experiments, it summarizes 6G fundamental use cases, user and application trends, usage scenarios, and gradually built a key technical performance indicator system. In June this year, IMT-2030 Promotion Group released a white paper on 6G vision and candidate technologies. This white paper summarizes the current study results and especially proposed 6G vision to realize an intelligent connection of everything, data twins society. 6G will transfer the Internet of Things to intelligent connection of everything. In our view, there will be 8 typical 6G use cases, which can be grouped into 3 categories. They are immersive, intelligent, and ubiquitous. Now we come to the various technologies. Currently, we have 11 task groups in 4 categories, including enhanced physical layer technologies, emerging technologies with convergence and integration, new physical transmission dimension, new spectrum-driven technologies. So far, there are 5 technical reports published from various technology working groups covering 5 technical research directions. I will go through the main contents for each research direction. With the emergence of new materials and technologies, the scale of the antenna array will be further expanded to support new scenarios and services. The research work on new application scenarios, especially new array structures and deployment methods combined with new materials, a further combination of AI and massive MIMO become popular research topic. For Tera-Hertz communication, we need to analyze new application scenarios as well as to do some basic research on channel modeling. In terms of key technologies, it's also necessary to carry out fundamental investigation on the basic physical layer technologies and consider the combination with sensing, AI, and other technologies. The realize of commercialization of Tera-Hertz will be largely depends on the maturity of devices and industrials, as well as the discovery of application scenarios. The integration of sensing and communication is a new research direction. The integration level of sensing and communication will evolve from function coexist to joint and signal design, and finally network materialism to realize deep information and network collaboration. For the key technologies, the task group is carrying out studies on basic serial, air interface architecture and devices. From the perspective of CG-oriented research, we can have an opportunity to build a novel wireless AI network architecture and air interface protocol to realize a new end-to-end network with native AI. Specific research will be involved, new high-efficiency AI machine learning algorithms, basic serial of computing, storage, communication, costs, and performance limits. Reconfigurable intelligent surface control signal propagation direction, suppression, interference, and enhance signal. It can be exploited in non-idle transmission scenarios, such as unlost conditions or cell edge error. Currently, we have conducting research on basic serials, modeling, technical solutions, and related algorithms. This will also invite many changes and innovations in new materials, radio architectures, and interface design. Now we come to the work in Network Technology Working Group. This group established 2+6 technical direction. 2 is the network architecture and network security. 6 is the 6 directions, including deterministic network, computing power network, information central network, digital twin network, intelligent network, and integration of terrestrial and non-terrestrial networks. In September, Network Technology Working Group published a white paper entitled 6G Network Architecture Vision and Key Technology Outlook. This white paper proposed compatibility and simplicity as the 2 principles in network architecture design with 4 highlighted characteristics. It also proposed 6 potential capability technology and 6 potential architecture technology for further consideration. Network Technology Working Group has also published a technical report on network security vision. This report starts with a driving force for 6G security development, analyze typical 6G scenarios and their security requirements, and then proposed a 6G security vision. The Spectrum Working Group has a task on 6G spectrum requirement study and global spectrum policies. Their work also includes 6G spectrum planning on the ITU framework, as well as to explore new frontier for 6G spectrum. Some spectrum-related technologies, such as spectrum sharing, also be included. Standards and the International Cooperation Working Group is actively build a communication and cooperation mechanism with global organizations. They are also responsible for the output from IMT-2030 PG to international standardization organizations. The Economy and Society Working Group currently use 5G applications as a starting point to analyze the relation between mobile communications and social economy. We will first analyze the application scenarios and business model of 5G in the national economy, and then expanded the research into 6G. To promote the healthy development of global 6G, I suggest first, the successful commercial deployment of 5G will lay a solid foundation for 6G. We should coordinate the development of 5G commercialization and 6G research. Second, this convergence of data, operation, information, and communication technology will be catalytic for the innovation of next generation networks. Third, is the mobile communication has been successful on the basis of global cooperation. We hope that 6G will continue to uphold the development concept of openness, sharing, and winning cooperation. Let's work together to create healthy development environment for 6G. Thank you very much.
Okay, thank you, Dr. Wang. And your presentation was really help us understand your IMT-2030 PG is also really enforcing the technical working group. So also we're looking forward to many cooperation opportunities in the working group, the level.